In this lecture, we look at transformations of functions, shifting the graph of a function either up, down, to the left, or right. In this course, we learn to identify a variety of functions: linear functions, quadratic and cubic functions, general polynomial and rational functions, exponential and logarithmic functions, trigonometric functions, and inverse trig functions. Many of these functions can be identified by their shape. We will identify some basic functions and then learn transformations of these functions that give the same shape. For example, the graphs of the functions y equals x squared and y equals 3 times x minus 5 all squared plus 7 are graphed below. They're the same shape. If one plots them on the x-interval from minus 1,000 to 1,000, one gets the following pictures. The graph of y equals x squared is on the left. The graph of y equals 3 times the quantity x minus 5 squared plus 7 is on the right. Only the labels on the y-axis have changed. All quadratic functions have a similar graph. If we learn the graph of y equals x squared on the left, we can always change that into the graph of a quadratic such as the one on the right if we understand transformations of functions. There are 4 types of transformations we will study in this section. In the first 2 types, we simply shift the graph a fixed amount either vertically or horizontally. In the last 2 types of transformations, in a later presentation, we expand or shrink the graph by a fixed amount either vertically or horizontally. In this presentation, we concentrate on simply shifting or translating a function vertically up or down or horizontally left or right. It's easy to shift the graph of y equals f of x up vertically by a fixed positive amount c. Just add c to the y value. That is, create the graph of y equals f of x plus c. If we can shift up by a fixed amount, then shifting down is also easy. Just make c negative. If c is negative, then the graph of y equals f of x plus this negative c. Shift the graph down by the absolute value of c. For example, if y equals f of x minus 2, or f of x plus a negative 2, that shifts the graph down by 2. Consider the graph of y equals x squared. The graph of y equals x squared plus 1 shifts the graph of y equals x squared up 1 unit, so that parabola goes up 1 unit. The graph of y equals x squared plus 3 shifts the parabola up 3 units. The graph of y equals x squared minus 2 shifts the graph of y equals x squared down by 2 units. Here are those graphs. In this picture, the dark black curve is the graph of y equals x squared. The green curve, shifted up 1, is the graph of y equals x squared plus 1. The blue curve we get by shifting the black curve up 3 is the graph of y equals x squared plus 3. And the red curve is the graph of y equals x squared minus 2, in which we switch the standard parabola in black down by 2. Horizontal shifts are very similar, but there is a subtlety here. Because the horizontal x-axis represents inputs to the function, if we want to shift the curve to the right in the positive x direction by a positive amount c, then we need to prepare the input by subtracting the amount c from x before it is inserted into the function. This will be the opposite of what one expects, but by subtracting c from x, by replacing x by x minus c, we make the input x minus c on the left of x act like the input of x, and this shift, moving x minus c to x, is a shift to the right. In the next slide, we will graph y equals x squared, y equals the quantity x minus 1 squared, and y equals quantity x minus 3 squared. Notice when we do this what happens when we replace x by x minus 1 and by x minus 3. Here's our graph of y equals x squared, the familiar parabola in dark black. Now, if I graph y equals the quantity x minus 1 squared, replacing x by x minus 1, I shift that black parabola to the right. And if I graph y equals the quantity x minus 3 squared, replacing x by x minus 3, I shift the parabola 3 to the right. Here's the graph of y equals x squared. Here's the graph of y equals the quantity x plus 2 all squared. Replacing x by x plus 2 shifts our parabola to the left by 2. And here they are all together. In black, the original standard parabola. In green, the parabola shifted to the right by 1. In blue, we shifted to the right by 3. And in red, we shifted to the left by 2. In this presentation, we examine shifts of functions vertically and horizontally. In the next presentation, we will examine expansion and contraction of functions.